Okay, here we go with some 3.1 and 3.2 review problems. When we start with the problem, what are the zeros of f of x equal 3x squared minus 3x minus 90? Now the zeros are x value such that f of x equals 0. In other words, we're solving 0 equal 3x squared minus 3x minus 90. And those solutions are our zeros. So we have a quadratic equation. I mean, we could just throw those numbers into the quadratic formula, get out a calculator and grind out the result, or try solving it by factoring. And in this case, it does factor. We can factor a 3 out to start, and then we factor the smaller quadratic, and we get 0 equal 3 times x minus 6 times x plus 5. By the zero product rule, we let each of those factors equal 0. And we get zeros of x equals 6 and x equals negative 5. Those are the zeros. Okay, now to the long division, the polynomial division. And a lot of people struggle with this. So we're going to do this problem. 2x to the fourth minus 2x squared plus 2x minus 2. We're going to divide that polynomial by 2x squared plus 2x. So see if you can set this up correctly. And remember, we need a 0 placeholder for the missing x cubed term. So set this up, pause the tape, set it up. So here's the setup. We have inside the divide sign 2x to the fourth plus 0x cubed minus 2x squared plus 2x minus 2. You'll see in a second why we need the 0x cubed term. We start this long division process by dividing the leading term inside the divide sign by the leading term outside the divide sign. So when we do that division, 2x to the fourth divided by 2x squared, we just get x squared. That's the first part of our answer. Then we take that answer and we multiply by the divisor. X squared times the divisor multiplies out to 2x to the fourth plus 2x cubed, and we're going to put that right underneath those matching terms. Now here we have the 0x cubed term that we can then subtract from, and that's why we need it. And our next step is to subtract. Now when we subtract those terms, we have to remember we're subtracting a polynomial. So you're going to subtract both terms. You're going to subtract the 2x to the fourth from 2x to the fourth. They're gone. We're subtracting a 2x cubed from 0x cubed, which gives us a negative 2x cubed. And then we carry down. Those are our 4 basic steps that we repeat over and over. And we're carrying down that minus 2x squared. Well, we start the process again, dividing leading terms. But this time our leading term is this negative 2x cubed that we got. We're going to divide that by positive 2x squared. And that will give us the next part of our answer. So when we do that division, negative 2x cubed divided by 2x squared, we get a negative 1x, or minus x. That's the next part of our answer. And we always take that answer part, multiply by the divisor, and put it underneath and subtract. So that's what we do next. So when we multiply out, we get negative 2x cubed plus negative 2x, or minus 2x squared, and then subtract. And then something kind of odd happens here when we subtract. Both terms subtract away. We just get a 0 and a 0. Because we add, when we subtract the polynomial, we add the opposite. So plus 2x squared to minus 2x squared is 0. And so then we carry down that next term, which is 2x. Well, we cannot divide 2x squared into 2x. So we cannot get another answer. And then we also have to carry down the minus 2. So I mean, you could write up here plus 0 and then get zeros underneath there and subtract, and then get another 0 and then carry down that minus 2, or get a 2x rather, and then carry down the minus 2 in another step. Or we can just carry down both those terms in one step. That's our leftover part. That's our remainder. We've accounted for everything except the 2x minus 2. So we would write that as 2x minus 2 over the divisor. 2x squared, or 2x minus 2 over 2x squared plus 2x. So there's our answer, x squared minus x plus 2x minus 2 over 2x squared plus 2x. And I know you could factor a 2 out and reduce that, and if you want, you could do that. But that is our answer. Okay, for our next problem, we're going to divide the polynomial x to the fourth plus 2x squared minus x plus 1 by this binomial x plus 1 using synthetic division. Now we can use synthetic division if we're dividing by x plus something or x minus something, a linear term. On the previous problem, we could not have used synthetic division. We had to use polynomial division, but here we can. So the first thing you do is set this up, put your value of c off to the left and all the coefficients, pause the tape and see if you can set this up correctly. And to set this up correctly, first of all, we have to account for all the coefficients. Our polynomial doesn't have an x cubed term, so that coefficient is 0. Also, if we're dividing, the synthetic division process works for dividing x minus c, so we have to think of x plus 1 as x minus negative 1. Our c value here is negative 1. So the c value goes off to the left, followed by all the coefficients and the L bracket. So here's the setup, our value of c and the coefficients. And then we start by carrying down that first coefficient, 1. Then we take 1 times our c value. 1 times negative 1 is negative 1. Goes in the next column. We add. 0 plus negative 1 is negative 1. Then we take that negative 1 down there times our c value of negative 1. And that makes positive 1. That result goes in the next column. Then we add. So it's always multiply, add once you get past that first entry. Then we take 3 times negative 1 is negative 3. That goes in the next column. Then add. Negative 1 and 3 is negative 4. And then we take negative 4 times negative 1 is 4. That goes in the last column. And then we add. So we get 5. So that bottom row gives us our answer, the coefficients of our answer plus the remainder. And so applying this, we have the values 1, negative 1, 3, negative 4, 5. Our answer is always going to be a polynomial 1 degree less. Because you're dividing by a first degree, that's going to reduce the degree of the answer by 1. So it's going to be 1x cubed minus 1x squared plus 3x minus 4. Our remainder is 5, so we write this as 5 over our divisor of x plus 1. And that's our answer at the bottom. And in the homework, the problem, I believe, was missing 2 terms, so you have to make sure and use 2 of those zeros in the homework problem number 3, because I'm looking at it, it's missing both the x to the 4th and the x squared term. Okay, in our next problem, find the 0 of f of x equal x cubed minus 2x squared minus 5x plus 6 by checking x equal 2, x equal negative 2, and x equal 4. Use the result to completely factor f of x. Okay, we're going to use the following that we learned in 3.1.3.2. If x equals c is a 0 of a polynomial f of x, then x minus c is a factor, and f of x equals x minus c, that factor, times whatever your division result is. We use this principle with the zero product rule. We factored our quadratic. We let each factor equal 0, and then we got the solutions, which we call zeros in this section. We also use this result of the zero or the remainder theorem applied to zeros. If x equals c is a zero of the polynomial, then f of c is going to be 0, which is the definition of a 0. But also, the remainder after dividing by x minus c is 0. Of course, because x minus c is a factor. You're not going to have a remainder if it's a factor. So, synthetically divide using c as each of these values and see which one of these three given values is a 0. The one that's a 0 will have a remainder of 0. So that's the next thing. Set up the synthetic division for all three of these and do them. So I'll pause the tape while you set that up, and then we'll come back to that. So I've set these three up on this tiny whiteboard I have here. Kind of crammed them together, but so we can show all three of them at once. So you should have a setup like all of these. The coefficients 1, -2, -5, 6. There's no missing terms. And then you put the c value or the given x value off to the left for each of these. So now do the synthetic division. Carry down that first coefficient. Multiply, put the result in the next column. Add, multiply, add. And then finish all the columns and see which one is a 0. And before we go any farther, I just see that I left off the minus sign with the 5. So each setup should have 1, -2, -5. You can get rid of those. And then 6. 1, -2, -5, 6. 1, -2, -5, and 6. So if you copied what I had here, correct that, and then go from there. Okay, now that we have that straightened out, done the synthetic division for all three of these, carry down the 1. 1 times 2 is 2. 2 plus -2 is 0. 0 times 2 is 0 in the next column. 0 plus -5 is -5. -5 times 2 is -10. Add to 6 makes -4. So this x equal 2 is not a 0 because we got a remainder of -4. Now we check -2, carry down 1. 1 times -2 is -2. Add to -2 is -4. -4 times -2 is 8. 8 plus -5 is 3. And 3 times -2 is 6, which gives us a remainder of 0. So -2 is a 0. And then we go to x equal 4. And doing that synthetic division, we get 18. So 4 is not a 0. But -2 is. So this shows us that f of x divided by x minus a -2 equals our division result of 1x squared minus 4x plus 3. We get that from the answer above. And remember, it's x minus a -2 that we're dividing by. In other words, x plus 2. But it also means, since f of x divided by x plus 2 is this answer, it means that f of x is x plus 2 times our answer that we got down here. X squared minus 4x plus 3. But we can factor that. We can factor that some more. The x squared quadratic factors as x minus 1, x minus 3. Now, even if we couldn't have factored that quadratic, we could have gotten solutions, in radical form, and we could have written a factorization, because those solutions would be zeros. So we'd have x plus 2 times x minus the first solution times x minus the second solution in whatever the radical form is, we could have factored this even if that quadratic didn't factor. But for these problems, I did make them factorable. And we'll just end it right here. This video is getting a little long. And we'll see you next time.